Some of you know my Bronco is a little bit of a Frankenstein. It's a mix of different years. It's an old 78 Bronco, and it's a resto mod that I took the guts out of a 2004 F-150 that had been wrecked and threw them in there. So I'm having some issues with the four-wheel drive, I think. I'm having some noises. So I tore the transfer case out, tore all into it just to see if there was any problems in there. I don't see any. While I've got it out, I thought I would talk about four-wheel drive, what it does, the differences between it and all-wheel drive. I just couldn't resist having it set up here on the bench. Let's have a look at this sucker and see what four-wheel drive is all about. So this is the front of the vehicle. So I guess I would be sitting in the driver's seat like right here, looking that way. So this is the front. This is the front drive shaft that goes to the front wheels, and this is what goes out to the rear drive shaft to the rear wheels. This is the one that's always being driven essentially, because four-wheel drive vehicles tend to be, you're driving around in two-wheel drive most of the time, just using the rear two wheels to send you down the road. And this is usually bolted right up against the back of the transmission. So you'll have your engine, then your transmission that decides how fast you're going to go, basically. And then, so this shaft is being driven anytime you're going down the road. So let's have a look at this. We're set up. There's a switch on here, and this is a electronic shift on the fly four-wheel drive. So instead of the extra gear shift there in the front seat, there's actually a switch on the dash, and I just flipped that switch to four-wheel drive. And in the truck it came out of, there were little it automatically lock in the front wheels so that they're not just spinning freely into the axles in the front drive shaft. And then at the same time, there's a little electric motor. So like I say, rather than having to grab an extra gear shifter and lock this thing in, there's a motor on there rotating a little shaft. So right now that shaft is in the two-wheel drive position, 2H, which stands for too high. So the wheels are going at a higher speed for highway speed. You could think of H as highway. And so as we're driving down the road, front-wheel drive isn't needed. So that the engine and transmission are turning this input shaft, and you can see that the output shaft that's going to the rear axle it's like they're just locked together. It's not the same piece of metal, I'll tell you that. It telescopes and slides in and has a bunch of splines and things that it engages in there. But currently they are locked as if it's one shaft. So it doesn't matter how many times I rotate these things, you can see they're staying aligned to each other. Now, if I'm driving down the highway and there's some ice or something, or I'm out four-wheeling and like, okay, there's some mud coming up, and I want to be able to use the front wheels. They're not just going to be along for the ride. I want to use them to help get me out of something. Or maybe I backed off the side of the road, and so my rear wheels are in the ditch, and I found some snow or some mud, and they're just sitting there spinning. Front wheels aren't doing anything. All right, I want to engage that front shaft as well. And so in old school truck, I just grab that shifter and shift it into 4-high. On this guy, it's shift on the fly, so I'd flip that switch, and when I flip that switch, it's going to rotate this guy in that direction. We can see it'll force this guy up to engage with that shaft. I'll help this guy up a little bit. Clunk. And that's our, now we're in four-wheel drive. You hear that? Clink. Now, these are one to one. These suckers are rotating together, and we're in four-wheel drive. And then we flip the switch on the dash, drop that back down. All of a sudden, now we can rotate in two-wheel drive and not be turning the front drive shaft. In fact, let me flip that back so you can hear it. We go into 4-high, and as I come up, you'll hear this clunk, Okay, it wasn't very loud. But now, check this out. You can see the front drive shaft. Everything is locked together. So this is what we're talking about when you hear four-wheel drive. It's that you have you always have a shaft going to the two rear wheels, to that rear axle, and we won't get into the details of that. But you've got this other shaft that goes to the front wheels, and for most of the time it's just sitting there going along for the ride. And the wheels aren't even connected to the axle in the front, that they're just along for the ride too. All you're doing is using them for steering. But when you engage, like with this guy, flip that switch on the dash and say, put me in four-wheel drive. What's happening? Well, the rear drive shaft and the front drive shaft are going, they shall rotate at the same speed. And that's fantastic when you're trying to get out of a slippery situation. What you run into though sometimes, and this is what the difference is between four-wheel drive and all-wheel drive, or four-wheel drive and full-time four-wheel drive, is I remember like when I was a teenager, backing my dad's truck off of the side of the road and getting some into the gravel, and it was like, okay, I'll just put it in four-wheel drive. I'd never done it before. And it, sure enough, the front wheels started driving and pulled us onto the pavement, but now all four wheels were on the pavement, and as soon as, if you're going in a straight line, it's no problem. But I had a little bit of turn to it, and you start to feel this hop, 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 and that's because anytime a four-wheeled vehicle is in a turn, naturally the inside wheel and the outside wheel are taking different paths. But also, if you just look at the marks of the tires in the mud sometime, or some wet pavement where you can see that, and the two front wheels and the two rear wheels, they're not traveling over the top of each other. They're taking entirely different paths, so they are going at different speeds. And that's where that hop is. Something has to give. If you're in gravel, or you're on ice or snow or mud, one of those tires can just slip and it's no big deal. That allows the front and the rear shafts to go at the same speed and rotate together. But if you're on the pavement, oh man, I mean, something has to give, and it's one of those tires is going to kind of just sit there and hop, and it has to continually do it until you get going in a straight line again. So that's what four-wheel drive is those two front and rear shafts, they're locked together. Now, if we're talking full-time four-wheel drive, which there were some of the older trucks that had a full-time transfer case, and that would allow, through some mechanism, they're going to allow these to have a little bit of slip with each other. And that could be what I've heard called a viscous coupling, where, yeah, you've got discs or a clutch or something where there's some load there where they're, I'll say, encouraged to go at the same speed, but you get into a pavement situation and they'll be allowed to slip. Or there might be like an open differential type situation where it's just balancing the torque between those two. And that's where you think more of an all-wheel drive, where you can kind of think of it like a geared teeter-totter, that if you load one side, that's where all the load is going to go. But if things are equally balanced, you're going to get a nice equal distribution of torque to both the front and the back. And I know, like the old Subarus, people would say, oh, I've got a Subaru, I'm driving all four wheels, so no problem. But I've heard of situations where they got one wheel off the edge of a parking lot where it wasn't touching the ground, and they go to leave and they're just stuck there. That one wheel is sitting there spinning in the air, and even though you have three other wheels on the pavement, that car's going nowhere until you can, like, okay, get some guys to help push the thing, or get some load on that front wheel. Where four-wheel drive, because those two front shafts shall move at the same rate, if those two rear wheels or two front wheels have traction, you're actually going to go somewhere. So there's a situation where you would want to have that four-wheel drive. Now, the newer Subarus, they've solved that issue. There are a number of ways to do it. They could do it through just braking. The computer could see that just one of the wheels is spinning, if they've got sensors on that one wheel that's in the air, and it could just apply the brakes to that one wheel, and then that would give enough resistance and equalize the torque that the other three wheels could now get that much torque and start moving until that tire is on the pavement, and then let go of that brake, and now you're good to go. They could do it through little temporary lockers. I actually don't know the details of how the most modern Subarus are doing it, but they definitely are. You go watch these videos now where they put it on some ramps with some rollers, and they'll show how their vehicles versus others, like a four-wheel drive, if you let one wheel in the front and one wheel in the back get on some kind of rollers, the whole thing, it won't go anywhere. Where the Subaru, all it needs now is one wheel, and it's able to drive up the ramp. So pretty cool stuff. But those are special circumstances, and I know we hear these four-wheel drive, two-wheel drive, all-wheel drive, full-time four-wheel drive, and so I thought I'd go over this real quick while I had this thing out and talk about that. Now, real quick, let's look at what the for low means on this type of transfer case. So we're going to flip this thing all around, and for low, you have to like stop the vehicle, put it in neutral, and then it'll allow you to put it in for low. In fact, this thing isn't going. There we go. Had to move it just a little bit to get it to go into for low. Now let's see what happens when we go to for low. I'm guessing this thing is going to turn more. These two are still going to be, oh yeah, look at that. So these two are still locked together because we want that front and rear drive shaft to travel at the same rate no matter what. But now check this out. I've gone one full revolution with this guy, and we've only turned what, a third of a turn. So 2 turns on the input, and we're still not all the way around. We're going to come up to almost 3 turns, so basically 2.5 turns on the input to get 1 turn on the output. So that's giving a mechanical advantage to the transmission. And now, if you've ever done that and shifted your truck or whatever it is into for low, man, you can be just the engine's running at a really high RPM, and you're just crawling up the road, which is really nice when you get into really slick conditions, or maybe you're pulling something. I know pulling stumps out with the Bronco. We got a neighbor or something, and they want to tug something out, and we just get a big rope or chain hooked onto a stump, put it in for low, and then just go for it. Say on the pavement, you want to be in a straight line. So that's pretty cool to look at that. Let's see if it comes all the way around. Wow. One more time. That should line us back. There we go. Now we're all lined back up. Doesn't really matter. It's just for the visual. But now let's take it out of for low, go back into for high with our little shifter. There. Now we're all turning at the same rate, so there's no additional mechanical advantage. This is ability to go highway speeds. And then once we're back out of the woods, we're done mudding, and we're pulling out on the highway. There's no reason to drive that front drive shaft anymore. We don't want to get that hop when we're going around a sharper turn, so we can throw it back into two-wheel drive, and now should be completely disengaged here, except for just a little bit, a little bit of fluid in there. But now we're back to just driving the rear drive shaft, and the front drive shaft is just along for the ride, waiting for the next time when you're going mudding or anything that you need, so you're not wearing out your U-joints and all that kind of stuff. So I'm going to throw this back in the Bronco hopefully today. Try to bench press this thing back up in there. The reason I have this thing out, had this noise the family was going to the woods just to have a campfire and roast some hot dogs. and this thing started, I was getting this kind of sound on the highway, and I pulled off the side of the road, and it was, even though we'd slowed down, it was still kind of at that same pace, and all of a sudden you hear this click and whunk, and it just stopped. Something engaged, and it was fine after that, and it didn't do anything. The couple times that it tried it again, I flipped that switch into four-wheel drive, and all of a sudden, just whunk, it would stop it. And so that told me, okay, it probably is in the transfer case. It didn't necessarily have to do with how fast we were going. I've played with this. This seems to work, but there is some weird, my four-wheel drive light on the dash has stopped coming on, or only coming on maybe 1 in 10 times that I'll see a little flicker, which tells me that the encoder on the back of this thing might be on the fritz a little bit, though every time I have my son flip the lever and I look at the position of this thing, you can see I've marked these, it's very positive, going one to the other, to the other, to the other. So my observation is this thing's working just fine, but it does make me wonder if it's randomly driving down the road, if we're getting like a half engagement or something. So I didn't see anything wrong inside the transfer case. So while we're out, check this out. I'm going to put it back in, and I might even just leave this thing off and see if the problem persists, or put a new one of these in here. But this is kind of how troubleshooting is. You hear a sound, and you just got to do some exploratory surgery. I'd rather not have to do it, but it's the name of the game. And I don't want to pay somebody else hundreds or thousands of dollars for them to learn about it. So I'm going to learn. I'll keep you posted on what I figure out with this thing. So hopefully that was some use to you. I'm Quint. Thanks for watching.